Hello, everyone. Good morning, good afternoon, good evening, depending on what part of the world you're in. This is Don Toll with SimData. I am our practice director for what we call simulation-driven systems development, essentially the integration of modeling and simulation with systems engineering. And I am very happy to be able to present to you today as part of the Data Advanced P7 Users Conference. And I will try to give you a very quick overview of some of the things that we see going on in the engineering market as it relates to digital engineering, digital transformation. SimData is an international consulting firm. We do project consulting work for both industry as well as the solution vendors like Data Advance. And we also have a market research activity that puts out a number of reports every year on the size and growth of the what we call PLM, but essentially the digital engineering software market. And so I'll talk a little bit more about that as we get further in here. At any rate, so there, as you all know, and as you're living, there are a number of major technology disruptors and trends going on right now around the industry. Things like, the cloud, for instance, that we'll be talking about, Industry 4.0, AI, machine learning, digital twins, and so forth. So really what we see is a lot of this is really causing a need for companies to relook at their business practices, relook at how they do product development, and really this whole area of digital transformation, digital engineering is being driven by a lot of these major trends, which we'll talk about here shortly. So the real key that we see that's driving a lot of this in the market today is that products, we say here commercial products, certainly in areas like automotive and consumer products, but even in areas of, military defense, shipbuilding, architecture, infrastructure, everything from a product perspective is becoming more complex. Now, certainly products like vehicles that are mobile, that interact and move, and now are part of an interconnected network, if you will, of systems and systems of systems. This is really driving a great deal of complexity as manufacturers need to look at how they design products for optimal cost, but also for safety. And so the complexity now is driving a lot of risk. So as systems get more complex and we start talking about much more electronics and software content, providing a lot of the functionality, there's new manufacturing processes and materials, things like additive and so forth. And we also want to have, green products that can be recycled, that have a minimal impact on the environment, all these things, shorter life cycles, and yet some long life cycles in industries like aerospace and defense and shipbuilding and so forth. All these things are making it very complex, but the digitalization that we see happening in the industry is a way to deal with that risk and also has an opportunity to capitalize on some of these trends. And really, what this is driving is that there needs to be more upfront cross-domain engineering done. And when I say cross-domain, I mean across hardware, software, electronics, and so forth that make up an entire system. So it isn't just one domain anymore. So the digitalization is driving a lot of these engineering trends that we're talking about. So there's a lot of investment for that reason in simulation, data analytics, and these other areas. These are a few of the major trends that we track on an ongoing basis at SimData. I'm going to talk a little bit more about democratization as we get further in here. Certainly model-based systems engineering is a term you're probably hearing, MBSE. How do we talk about, really digitizing that upfront part of the product conception and ideation process, if you will, starting with the voice of the customer requirements and looking at the functional logical design, even well before we get to any kind of 3D representation of the system or subsystems that are involved. So that is a big focus now in industry. That is also leading to thoughts around things like digital twins. How do we look at creating a digital representation that is going to live throughout the life cycle with a physical asset? And then how do we connect that information as part of a digital thread? And then again, all of this is very much tying back to some of the new technologies that are coming by virtue of smart connected products with Industry 4.0, data analytics, big data, artificial intelligence, machine learning. How do we use some of these new technologies to make it more practical to have the data and the information available to engineers throughout the life cycle? So we'll touch on, again, some more of these as we go forward. The movement toward this model-based future has been in process for quite a while, as I'm sure all of you are aware. Really starting back in the '60s and '70s when we first started developing more formalized software programs for doing engineering. You could argue it was even before then, but this whole concept of the system engineering V on the left has been around for many, many years and has really driven a lot of the thinking about how to think about designing and developing products and bringing them to market. What's changed in the last, certainly in the last decade for sure, is that instead of just kind of going off and being a disconnected activity on the right there, once we turn the product loose to the market, if you will, this whole idea of a more of a circular and holistic life cycle has emerged. And the idea of the virtual and the physical really mirroring each other and coming together. So the people from Boeing Aircraft over the last several years have put together this idea of the diamond as opposed to the V, which is essentially two V's if you look at it, one on top of the other. And it's really the idea that we need to track the virtual along the life cycle with the physical, and modeling and simulation is a key part of that along the virtual realm. So, this idea of going from a document based process to a database and a model based process is really what we're talking about with this whole idea of digital engineering, digital transformation. The the digital thread I mentioned very briefly here, lots of terms around that today, but at SimData, we talk about that as the communication framework. So, how do we enable this idea of information and data flowing across an enterprise and going through the various domains that you see here represented as bubbles? And these by no means are everything within a traditional enterprise of a day, but they are kind of the main areas where you see different kinds of tools, different kinds of data architectures and representations for a product as it goes throughout the life cycle. So this idea of a digital thread is how do we enable this end-to-end process by connecting models and data as part of this MBE kind of vision. And as the digital thread concept has evolved here over the last 4 or 5 years, now we even start talking about really not just one thread. So the idea of the fact that there's many threads through a enterprise and through the life cycle of a product, depending on what area is being looked at, what domains are being touched by that data. So the idea of a thread is really many threads, right? So there are many threads through an enterprise, and these threads are not linear. They're not necessarily all looking the same, and they can go different directions depending upon the kinds of things that are being predicted and the kinds of information that we need to connect to make decisions, depending again on whether those decisions are in the early part of the life cycle or more downstream in the operations life cycle. So again, you'll hear the term digital thread, but you'll also maybe hear the term digital web coming up now. So the trends, these are again kind of picking out a few of the ones that I mentioned here. How are we addressing some of these challenges? Well, the industry, this idea of a thread, a digital thread, and the ability to use this data across domains is really driving the need for interoperability of data and models, exchanging information across domains. So data standards are really becoming more important in that context. There are a number of different standard organizations, OMG and ISO and STEP and so forth. And I won't get into all those here, but the point being that there are a lot of things coming up now where these things are going to become more important because we have to have a way that companies and their supply chains and their partners can share this information digitally. Instead of using documents now, we want to share models, we want to share digital information. So I'll talk a little bit that in a minute. The idea of there are definitely some areas that I believe, like MDAO, which certainly is an area where DataVance is very active, and SPDM tools with system engineering tools. Some of these technologies that have been around a long time, like MDAO, now are becoming much more important to be used, especially early in the life cycle, but really throughout the life cycle to optimize the performance of products. And then I mentioned bringing in some of these new technologies like AI and ML for digital twins and for really what we call augmenting the intelligence of the human, not artificial, not replacing the human, but augmenting the intelligence for decision making. And then finally, this idea of democratization. How do we get the information? How do we get the use of the tools and simulation results distributed to a wider audience in an enterprise and perhaps maybe to people that aren't really experts in using the tools themselves? But how do we let them take advantage of that information? So that's part of what we're going to address here. So I mentioned standards. Here's a chart that is a bit of an eye chart. Lots of different standards on here, but it shows you the different bodies and kind of where they fit in the life cycle, and also shows that there are even informal standards, things in the yellow here that I've talked about with the Microsoft Engineering Suite, as I call it, Microsoft Word, Excel, and so forth, and also there are new standards like MOSEC in the simulation area that are, definitely uh, emerging here to be able to integrate the system engineering world with the modeling and simulation world. And so these things are, if you're not familiar with them, things like FMI, FMU are particularly relevant in this case. So the digital twin, I mentioned that it's a digital surrogate of a physical asset. It's how the information is going to be captured and used with the physical asset across the life cycle. So this could be in the design of the product, in the production of the product, or the use of the product. So all of this is really enabled by these MBE type processes. And how do we connect that data? So the idea of standard processes and process automation, being able to bring this information together is very key to a digital twin kind of capability. So the digital twin is an area where we've done a fair amount of research over the last several years at SimData. I'm just going to show you a few examples. So where are people thinking about? This is from a survey that we did a couple years ago in conjunction actually with Altair Engineering. And you can see that people are thinking about digital twins across many different domains: manufacturing, engineering, data analytics, physics-based engineering digital twins, where you have both the data and the physics-based models as part of the digital twin representation, maintenance, operations, and so forth. So there are many types of digital twins, and there are even many types of digital twins for a given system, right? So a given asset might have multiple, and often usually will. So the adoption of digital twins, we asked the question of people, where is your company in the implementation of digital twins? So you can see here, a lot of people have been in, some people have been in production, but I'd still call them the early adopters, early, 20%, but you see that moving very rapidly in terms of what people are predicting going into production, into pilot, and certainly doing investigations. So, and this data again is a couple years old, so we're already down that path a couple years, and we're seeing this accelerate even more in some of the more recent questions we've had with some of our current customers. The digital twin, why are people interested? So what are people thinking they're going to get from utilizing digital twins? So the idea of get it right the first time and work with people across engineering functions. How do we have better understanding of the product and that includes in the early stages, but also importantly, as the product goes into service, right? So now we have information coming from various sensors, various data that's being collected from a product as it's being used in the field. And this is knowledge now that can be fed back into the engineering organization and used to essentially fine tune those products. It might be a product upgrade, it might be a warranty issue that needs to be resolved, it might be designing the next generation of the product. But that knowledge is really important as we start to bring information in from the actual customer environment. So the adoption of digital twins, it's interesting. We asked the question, same questions, and segregated it by the people that we had in management functions versus what we call technical specialist user functions. And you can see the management here is a bit more optimistic about where they are today and where they'll be in 5 years versus the users. And I think that's a function of probably the management not being as familiar with some of the details, maybe hearing a little bit more at a high level what's going on, whereas the users being more down, where the work is getting done, if you will, and understanding some of the challenges. I think this points out the need to really be very clear with your management on what's doable and what the benefits and the time frame of realizing those benefits is going to be with digital twins. Cloud is another area where we ask a number of questions. Again, this is just one of the application areas that we focused on. But again, you can see cloud is expected to grow significantly in the engineering space over the next several years, and that really has been accelerated by some of the new software vendors that are coming online with cloud native products. An example being P7Enterprise here with the DataVance folks. So there are a lot more options, if you will, for the engineering community to take advantage of the applications in the cloud, and we see that growing fairly significantly over the next several years. The adoption of digital twins, what are the challenges? What are the roadblocks that people see? It's interesting that the top two are related to lack of skills and simulation and lack of resources. I think this very much talks to this issue of the need for democratization of the tools and the information. How do we make it easier for everyday design engineers, manufacturing engineers, field engineers to use the information from, say, a digital twin or a digital prototype, and how do we get that information in their hands? So the idea of being able to take the best practices and the knowledge of highly skilled simulation experts, especially people in advanced simulation and things like multidisciplinary optimization, which are very much usually PhDs or technical domain specialists. How do we capture that information and get it in a usable form by the rest of the organization? So that definitely is seen as a major challenge by people. And certainly that is a lot of what the pSevenEnterprise, P7 environment is trying to enable with things like best practices capture, standard applications, and democratization, sharing those things through the cloud. So this is very much in line with what people have seen as a challenge going forward. A couple other areas here I'll just mention in passing, but how are software vendors addressing some of these challenges as well? So there is a lot of work going on across a number of the major vendors, including DataVance, for how do we augment this human decision making and this democratization, as I mentioned. So how do we present the information in a very interactive, easy to understand user interface that's custom tailored to the person's job? So don't give them everything in the software, just give them what they need to see, how they need to see it, how they need to use the information to make decisions. How do we bring the requirements across domains and present that information in a system context? And how do we really automate this exploration of the feasible system design space? So that's really where tools like in the MDAO space can really bring a lot of value, because again, with simulation, it's really never been deterministic. Everything is variable in the world. And now that we have customers using the information, using those models in operations, now we can really understand, did we make the right assumptions on the use cases and the range of operations? Very often, a manufacturer will find that customers are using things in ways that weren't even envisioned and really weren't designed into the product. So now we have a feedback loop on how to do that, assuming we can get that information in a form that's usable for both optimization and this idea of uncertainty quantification. So how much risk do we have given where we are in the design space, and even visually, can we experience that with things like VR and artificial reality? So there are a number of things going on in this domain that you'll see coming out from the software vendors, already in place in some cases, and certainly moving very rapidly toward commercialization. So this is an exciting area that I think you'll be seeing, in as well in Datavance as well as other tools. So key drivers, this idea of analytics, machine learning. Again, I think we're still early in the stage there. You can see where people are today. A lot of it is still experience based. Hate to say it, but spreadsheets, which are still the most widely used engineering tool in the world, but it is going to be changing, and it's already started, and we're going to see a lot more things around BI, business intelligence, data analytics, digital twins, and using AI and machine learning to replace some of the more manual types of processes and data usage analytics that we've had from things like spreadsheets and textbooks and things of that nature. So we, again, moving away from that world into more of a data driven, model driven kind of world is where people see this going. So the final point I want to make here is that, we've talked a lot about the technology trends, but in the work that we do with industry, we always find that the people and the process aspects of this are just as important, if not more important than the technology. So getting the right culture in place, helping people understand why we're making changes to model-based processes, digital processes, training people, giving them the tools, but also giving them the understanding of how they're going to use the tools, and then growing the talent that's necessary in some of these new paradigms. And again, this idea of democratization is a key part of that that can help address some of this issue. So I mentioned that we do a lot of market research at SimData, just to reinforce the point about the growth in the simulation analytics realms. Simulation analysis in the mechanical realm primarily here is what we track. There is simulation analysis in some of these other realms like EDA and AEC as well, but we don't have the data to break that out. But it's a significant part of those domains as well. But at least in the primarily mechanical realm, this has been one of the highest growth areas over the last really decade and a half, and we see that continuing going forward. Low single digits. I think we're already going to be over 10% for 2022 based on some of the results that we've seen from the major vendors, the market leaders so far this year. So again, high level of adoption of these tools that you folks are looking at with the P7 environment, and also the tools that you're interacting with as part of that environment that are, complementary, CFD, FEA tools, those types of things. So at any rate, that is where we are. And just wrapping up here, uh, again, mention smart connected products. This is really a big driver for this need for digital engineering. Uh, the business drivers, innovation, quality, and speed certainly is always the why. And we believe that model based engineering is going to be the how, right? Simulation and analytics are key to that whole model based engineering process. And many companies, while they're still spending heavily on PDM, CAE, and so forth, we do feel there's a need to get past some of those core elements into some of these underutilized areas like MDAO, like uncertainty quantification, and then enable that with simulation process and data management. So part of that is really enabling, again, this idea of digital twins that live throughout the life cycle. And then as I mentioned, digital twins, data analytics, AI, ML, all these things, and the data interoperability standards are going to be what enable us to use these digital twins to be able to validate them, make sure they are accurate and predictive of the performance aspects that we want to be able to predict once we put the system in the hands of a customer, and then to optimize over time. And as I mentioned, these processes, the culture, and the people skills are really critical to the business success that we see as we work with our major industrial customers. And so, with that, I'll wrap it up. I thank you for your time today, and I hope you have a great user conference with the Data Advance folks. Thank you very much.